So welcome back to the All About Go video series. In this video we want to look into the basic data types and declaring our first variable. I'm right in here after our Hello World project. I deleted the additional modules because we don't need them, and to quickly describe the basic types, I'm gonna do a multi-line comment, which I do by putting a backslash and a star, and in between these I can write everything and won't be interpreted as code. So basically, let's start off with a bool. Bool is a data type which determines true or false, just these two, and it's 1 byte large. So what is a byte? A byte is basically 8 bits large, and the bit is bit can only hold one binary number, and the binary number, we'll write this out, and the binary number has only a base of 2 in its numeral system. So this means we get 0, 1, and we will go into the next 0, 1, 0, 1, 1, 0, 1, and so on, which you probably know. Maybe you heard computers are just 1 and zeros. And yeah, that's exactly where it comes from. So underneath everything, these data types you work with, or you see in all these programming languages, they're basically just this. So these right here are already 8 bits. So 1 byte. This right here. So a bool will probably just 0 or 1, so we got only this or this for bool. And well, this would be true, this would be false. What if we got more than that? So we can also declare an integer, which is basically just a number. Let's say we use the code here, and we got like an integer, which shows int 8, 16, 32, 64. And this right here will basically just use the ones which the compiler defines. So if I'm doing a program for 64-bit PC, this right here will be interpreted as int 64. If I do a program for a 32-bit PC, will be interpreted as an integer 32. Let's take an int 8, just the shortest, or like the smallest, which is also just 1 byte. So it's also 8 bits large, and that's why the number 8, int 8. So an int 8 can also be this right here, because it can be any number, right? But we want to know, like, these 8 ones, like what basically do they mean? So how do we calculate this? We can go about using 2, up 0 for the first position here. We start by the end, plus 2 times the next position, like first position, second, plus 2, 2, and so on. to get all the positions. You know it from our base system, when we go like 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll switch into the next position and go again 1, 0, 1, 1, 1, 2, 1, 3, 1, 5, and so on. So obviously this number in binary, as it is in our system, in our decimal system, is a larger number. So that's why we start at the back of it. And you know, after some time, you know these values out of your head. So this right here is a 255 in decimal. So we get a maximum of 255. Let's do this shortly. We will declare a new variable, which in Go, which works with var. Let's say I for integer, and int 8. And we say I equals 255. We want to print on the end. So now everything is fine here, but he says I cannot use 255 because it overflows. Well, why does it overflow if I have a maximum of 255 here? Well, an integer can be negative and positive numbers. So this means it needs to have the space to be in the negative and positive area, and this means we need to quickly get the half of it. Let's just do this. Comment this out so we can run that. So we got 127. So I will put I in here again, save that, try 127, and this will work. So I can also put minus 127, and this will also work. Note that that an integer can't be fractional, so this won't work. Can't be fractional. So obviously, if you get int 16, you get 2 bytes and 16 bits, and this will be a lot larger. I don't have this in my head, but yeah. And we can now do 255, for example. This will work. So the next base type would be a uint, an unsigned integer. Let's put uint here, and we got it again. This will be either 64 or 32, or I can choose the one I want underneath here. So let's do uint 8 again, which is also 1 byte large. Let's fill this up again at maximum, and we do uint 8 here. We save it, and we'll run out of the box. This is because a uint can only be positive. Can't put a negative number in here. So if we are 255, we can go to 256. Yes, exactly. This will be the overflow. So this is an integer, an unsigned integer, can only be positive. And again, not fractional. So what if you want to do fractional numbers? We want to go about a floating point. Just float 32 or 64. There are only these two. And Go doesn't has a shortening for it, which is just float, and you will select the 32 or 64 version. In many languages, this would have a shortening too, which is just float. Yeah, and at this point, this will work out of the box. You should know by now that float 32 would be 4 bytes. Which would be 32 bits. That's why the name. So a float or a floating point, let's write it out, can be fractional and also negative. As you can see. With a float, you can also see that the overflow won't be detected, will just be shortened then, as you can see here. Just remove the rest of it. It's more about, like floats are more about how precise something is, because you don't want to use it for whole numbers at all. And yeah. So I wanna quickly go into why I'm describing you all of this, because most developers today, I think, wouldn't check how much or how large all of these types are, and they don't really care. But the thing is, you know, why if I'm having a number, I'm defining a number, and I know for sure it won't be larger than, let's say, 20, or won't go negative. Why the hell would I use a normal int? You know, you normally just write int just like this, and you don't care. You don't care, it's fine, you have what you want. But right now I'm using 64 bits for that. Even though I know that this will only be 255 negative. At least for the whole program. So I'm wasting basically all these bytes for nothing at this point, and I think, you know, today these values don't matter that much anymore. In the back in the days they did, but right now it's probably not noticeable. Still, if I go about this declaring my new variable which I want to use, I want to think about for what I use it. It makes you look ahead on what you want to do, which is a good coding practice, I think. And it's also really clean if you think about all this stuff before just declaring anything. And yeah, looking ahead in code is really important, since you will be finding yourself a few times at least doing stuff you don't need to do, or like doing mistakes or deleting your code again because you made a structural thinking mistake. Happens often, especially when you go about bigger projects for the first time, or bigger functions at this point. So now continue with the types. We want to go with a rune. Rune, I've only seen a rune in Go so far. Don't know this from another language. So we do R rune, and this can be, like for example, an H. Can be any character, Unicode character, but only one. So this is an illegal rune syntax, for example. And the rune, on the other hand, is, by the way, also an integer 32. So we got 4 bytes, 32 bits. And yeah, basically this is also how you get text into your programs. Basically, Unicode is a system which describes a decimal number for digit or character or yeah, anything. So right now it's 36. So what the PC, as we described before, doesn't use literal numbers, doesn't use literal letters, or can't work with it. So you gotta interpret it on a way which you can see at the end. And how do we at the end can write a whole sentence, or like even more, like hello world from my new program. So this will be a string then. And a string normally can be actually it's just an array. So an collection of several letters or numbers or anything, symbols, characters, which you have in your text, and it's nothing you have basically in any programming language. You have it in many, but not any. Underneath the hood, maybe from C, you still got you would still have an array which you can describe and go like this with these brackets, and you would have something like, get your array of runes, and then you can define every rune. Oh, I need to use this. So this would be this is actually what the string is. It's just this is the same as I would do string hello. Let's do another S string here, and this can be hello. This is actually what the Go compiler in this moment does underneath the hood. So all of these are just elements in memory. And the thing about this right here is we can really say that our string is let's say 64 bits, because right now this is just a collection of these runes, right? So we got a collection of single runes, single letters, characters, which are all 32 bits. So this I can do even more, and it would just go longer and longer. Can do spaces as well. so we can really say how large the string is. Arrays though in Go have certain functions to use. So I can say len of r. Let's say we wanna know how big our string is in memory. We could say, and then we have 32 bits, so we do times 32. We can say one print I. So this is right now the amount of bits this one uses in our memory. But let's go deeper on this arrays here. So what are basically arrays? As I said again before, it's a collection of data types, and we know for sure when we allocate these, they will be after each other in memory. Like every one of these, let's say again for our we have our int array here, again these brackets and int, and we say it looks like this. So every one of these maybe was also 255. Let's say uint 255. That's here as well. Print our array at the end so it doesn't cry. So all of these right now, not right now, but when I run it, will be in memory after each other. They will literally stand behind each other, and that's why you also let's say I only wanna know one number of these. I say these again and say 0, for example. And 0 right now just indicates the position of each of these elements. So if I do 0, which is the first position, I get 2. Say 1, I get 3. If I say 2, I get 255. So what I have here, or what I work with, is actually just a reference to these numbers in memory at a certain position. And like I said before, I can also say I want to have the length of my array with len keyword, and it will put 3. So why do I tell you this? This is not really that much important in Go. You won't face you probably won't face anything this is useful for, but in even lower programming languages, like for example C, you could actually say I want to use array and position 5, which I don't have. I don't have position 5 here. And this will just say, this will immediately say this is an error and I'm running out of my range. But actually, if you allocate, you can actually allocate numbers manually after this array, and this could work. So I'm pretty sure this is an automatically panic routine in Go, which will always fire no matter if there's something in memory, because okay, this memory can either be not available at all and should be an error, but the memory after these three numbers could actually be available and accessible. And in this case, I could also reference it and print it out and see what what is there. This can be really interesting because this is also a way, or kind of a way, how security problems will be found in programs, or like backdoors in programs, because people just access the the current memory, and with a bit of luck they get into the memory they want to change, or they want to get information of. And yeah, this is also described as a buffer overflow attack, which is one of the most common ones which are happening. So at this point, I wanna go into even more Go types and or like more specifically Go types and structures as well as functions. But I will do this in the next video because this one's going too long for that. So yeah, I hope you enjoyed, and as always, I'm doing Fiverr tutorials as well and selling my work there, so check that out in my description. And yeah, I hope to see you again in the next video.